Hey everyone, in this video we're going to be looking at the big ideas for section 3.1 part 2. So let's talk about interpreting R. Well, R is the correlation coefficient. You need to know that vocabulary. R is the correlation coefficient. And when we are asked to interpret R, that's very, very, very similar to describing the relationship between the two variables if we're looking at a scatter plot. So the first thing that we need to describe and talk about when we are interpreting R is the direction. Is it a positive relationship or a negative relationship? Is it positive or negative? And that is based on the value of R. If you have a negative R, a negative correlation, then it's negative. If you have a positive R, a positive correlation, then it's positive. The second thing that you want to look at is the form. If you are using R, then you always have a linear relationship, or you are assuming that it is a linear relationship. So if you're using R to describe the relationship, then you need to say that it is linear. If you look at a scatter plot and it obviously is not linear, it's non-linear, then you should not be using the correlation coefficient to describe anything about that relationship. Lastly, we want to look at the strength of the relationship, and the value of R helps us describe the strength of the relationship. If we have a -1 or a +1, we're going to say that's a strong or very strong relationship. The closer, actually what I should say is the closer we get to -1 and the closer we get to +1, the stronger the relationship gets. If you have an R or a correlation value that's around 0.5 or -0.5 or +0.5, we need to start using words that end in ly, like fairly strong or moderately strong. And then if you have something that gets close to 0, if you have a correlation value R that is close to 0, then we're getting pretty weak. So just keep that in mind as you look at these numbers. There's no perfect words or description that goes with each one of these, but just know that we should be using words that end in ly, and the closer you get to -1 and +1, the stronger the linear relationship will become. The next step, or the next big idea that we want to look at, is just some facts about correlation. So the first fact that we need to know about correlation is that R does not have units. There are no units on R. The second fact that we need to know is if we switch the axes, it does not change the correlation. It does not change R. So if we switch our explanatory variable, which is our x variable, with our response variable, which is our y variable, if we flip-flop those, R is going to stay the same. The correlation is going to stay the same. All right, the third fact that we need to know is that outliers in line with the pattern will strengthen R. Let me give you a little example of that. Draw a little picture here. If this was our scatter plot like this, and we just had these dots, and then we had this one dot way over here, this point right here is in line with the other ones. So this outlier, which is far away from everything else, let's put another dot in there, this outlier over here on the right, which is far away from all the rest, it will strengthen R because it is in line with the rest of those values. But let's do a little erasing here. If this outlier was not in line, I'll change the color of it even. Let's say here is our line. It looks like things are going like that. And all of a sudden, we've got this one dot way over here. That dot right there, if these black dots are the majority of our data, and it looks like the relationship is pretty linear right here, but we've got this one dot, this one point, I should say, over here. That is an outlier, but that outlier is not in the pattern. And therefore, that outlier is outside the pattern, and it will weaken R. It will make R, the correlation, a weaker value. Okay, so keep that in mind as you are talking about correlation. The last big idea that we have here is this, that correlation does not equal causation. Just because there is a strong, like let's say that there's a strong negative correlation, like negative 0.99, that does not mean that one variable causes the other. A strong correlation does not equal causation. So that's all the big ideas that we have for part 2 of this lesson. Hopefully this helps, and hopefully you have a great day.